to make you understand what about statistics, right? Now here the main thing today is interaction between features. What do you mean by interaction between features? So, or we can also call this as relation between features or relation between attributes. What is the relation? Is it whether it is a strong relation or weak relation? That is what we are going to assess. So this is also called linear relation and non-linear relation. We'll show this with a graph. Linear means a straight line. Non-linear means a circle or semicircle, something like that is linear. Now, what do you mean by positive relation and negative? We will see these two terms in the coming slides, right? Terminology. What do you mean by random variables, my dear friends? What do you mean by random variables? Normally, suppose if you say marks of a particular section, Virendra got some 82 marks, Lakshmi got some 92 marks. These are all definite. Definite. That means there is no sample. It is not a sample. It is a data. It is data. But ala kakunda, suppose for example, if you want to population, if you take population, where we take samples, random samples, based on that we will estimate. That is called random variable. Random variable is not, no, it is exact. It is exact, but not all samples are available. Not all samples are available. Only some samples are available. Such is called random variable. What is variance? What is sample mean? What is covariance, correlation coefficient, standard deviation? We will talk about all these parameters of statistics. Let us see now. Now, what is standard deviation? So, standard deviation is one calculated very easily by adding. This sigma refers to addition. This sigma refers to always addition, and xi is our individual element, and mu is our mean, and n is total number of samples. Let us see with an example, then you will be very easily convinced what is standard deviation. Right, this is an example. Standard deviation, you can see the marks of a class of 8 students are like this: 2, 4, 4, 4, 5, 5, 7, 9. The mean is called average, just an average. The mean or average of this particular is, no, so if we add all these things, you'll get 5. This is called mean of mean. Now, what is standard deviation? Standard deviation is you have to subtract the mean 5 from each sample. See, the samples are 2, 4, 4, 4, 5, 5, 7, 9. So you have to, sigma square is equal to 2 minus 5 whole square, 4 minus 5 whole square, only again 4 minus 5 whole square, 4 minus 5 whole square, 5 minus 5 whole square, something like this. So it will all, when summed up, it gets you 32. So 32 by 8 is equal to 4. So we say the standard deviation is square root of sigma square. It is called 2. This is how standard deviation is measured. Standard deviation is measured. Here, sigma is called standard deviation. Standard deviation, very important. So now xi, each value from the population. Xi, each value from the population. Mu is mean, and n is the total size of the population. And such all are added, summed up, and then it is square root. So this is called standard deviation. Standard deviation. Right. Next. Now, in order to understand the relationship between two variables, let us have a small example, my dear friends. This is very important example. Please have a look at this. If you see here, do heavier cars have lower mileage? ఏదైనా కార్ వెయిట్ ఎక్కువ ఉంటే మైలేజ్ తక్కువ వస్తుందా? దిస్ ఇస్ ద క్వశ్చన్. అండ్ వీ హ్యావ్ ఎ శాంపిల్ డేటా ఉన్నది మన దగ్గర. sample data on the entire data miles per gallon, 18 miles per gallon. Weight of the car 3,504 pounds, and the name of the car is Chevrolet. Now this Chevrolet car weighing to 3,504 pounds and giving us 18 miles per gallon. Similarly, such 400 or 500 data is available in a CSV file called Python data frame, right? Whatever it is. Now a graph can be plotted. A graph can be plotted by putting weight, the dependent variable, or the independent variable. The question is, do heavier cars have lower mileage? So here the mileage is independent, and the mileage is dependent, and weight is independent. So if for each weight, we calculate what is its miles per gallon. See, for 2000 weight, what is, see for example, 3,504, 18, 3,504 comes something like this, something here, something here. 18 comes something maybe here. This is our point. So this is how a graph is plot. A graph is plot just like this. So if all the 400 samples are placed like this, in reality, we can't do this. But by using Python, by using machine learning, we can plot a graph like this. Now tell me, can we calculate, can we assess? So can we assess now? Do heavier cars have lower mileage? So by looking at this graph, we may not in a position to assess. But definitely, as weight gets increased, the miles per gallon is getting decreased. See, the miles per gallon getting decreased. So this is how, right. Now let us see what are all the possible relations we have. See, these are the positive. This is called positive relationship. That is, a graph, when a graph is plotted, when x and y, on x and y, so if a line is drawn, if the line goes up this direction, it is called positive relation. Positive relation. That is, if x increased, y also gets increased. If x is increased, y also gets increased. Now, what do you mean by negative relation, my dear friends? Here y is taken and here x is taken again. Now, what is the negative relation? Negative relation means, see, a line falls like this. That is, if x is increased, y gets decreased. If x is increased, y gets decreased. And there is no linear association. See, something like this. This is a circle, like just a circle. So where you cannot assess. So this is called no linear association. You don't have any. This is non-linear association. We can say non-linear association. So this is called. These are the three types of positive relation, negative relation, and non-linear relation. Let us see now example. Now we have seen. So this is a real graph, my dear friends. Real graph. And this is our understandings: positive relation, negative relation, and no relation. Let us see what do you mean, how to calculate variance, and how to calculate what do you mean by variance and what do you mean by covariance. How do we calculate? For example, you take a positive relation. Take a positive relation. These are the points where how these points were plotted by using the data. By using this data, we plotted some points. Now, let us take approximately center point of for this. Approximately center point. Approximately center point. This might be the center point. See, This is X and this is Y. Approximately center point. Approximately center. Call this as Y bar and call this as X bar. X bar. Now take 2 points. See, these here some points are there. Here some more points will be here. Here also some points are there. Here also some points are there, my dear friends. Now this particular portion is called first quadrant. First quadrant. First quadrant. This is called second quadrant. This is called third quadrant. This is called fourth quadrant. Now, if you see here, there is a conclusion here, my dear friends. I'll tell you the conclusion here. See, this is first quadrant, this is second quadrant. Now, if you see this, the first quadrant and the third quadrant are positive by nature. How do you say this? See, this is called variance of y. See, for example, you take a point x, y. X, this is x. See, this is x, and this is y. You take a point x1, y1. X1, y1. Now, what is the difference between y1 and y dash? Where y dash is the approximate center, y1 minus y dash is called the variance. Is called the variance of y. Variance. 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 This is called variance. This is called variance. Similarly, this distance is called variance of x. This distance is called variance of x. Suppose if we calculate what is this distance approximately? Tell me. So if you see, this is y1 is always greater than y bar, and here x1 is greater than x bar. So the difference is positive in nature. This is positive. This is also positive. See, this is positive and this is also positive. This is positive and this is also positive, my dear friends. So, and if you take this, if you consider this, so the formula would be like this. x1 minus xi. See, x1 minus x bar and y1 minus y bar. Variance is equal to x1 minus x1 minus x bar, y1 minus y bar. So this is called variance. So variance is equal to, it's very difficult to write anyhow, right? So I'll just write here and so the variance is x1 minus xi. Similarly, y1 minus yi. In the first quadrant, x1 is greater than xi, x1 is greater than x bar, xy bar. Similarly, x bar. So the variance of this particular point is x1 minus x bar, and this particular point is y1 minus y bar. So for this particular point, x variance is x1 minus x bar, and y variance is y1 minus y bar. So good. Now, what do you mean? For all these points, what is the variance of x? Suppose if you are requested to calculate that, now you have to sum up all x variances. All points x variances you have to calculate. See, for example, all the points in the first quadrant will definitely have a positive value. Will definitely have a positive value. And all the negative, a third quadrant, if you look at the third quadrant, ఈ థర్డ్ క్వాడ్రంట్ లో ఉన్నటువంటి వాటికి చూడండి ఏమవుతుంది. ఇఫ్ యూ కన్సిడర్ ఏ పాయింట్ హియర్, ఇఫ్ యూ కన్సిడర్ ఏ పాయింట్ హియర్, ఈ పాయింట్ లో x1 బార్, suppose if you take a point here, if you take a point here, this is x1 and this is y1. So this x1, and if x1 and x bar are compared, x1 is definitely less than x bar. Similarly, y is less than y bar. That is, we'll get a negative. This distance is negative and this distance is also negative. But these two negatives, so for example, if you consider this is a star, then these two negatives becomes positive. These two negatives becomes positive. So we can definitely say now this is positive and this is also positive. Now, how do you calculate? And if you see the third quadrant or second quadrant or fourth quadrant, if you see here, if you take a point here, my dear friends, so this is just like this, and that is x ఏమో negative, y ఏమో positive. And if you consider this, ఇక్కడ చేస్తే ఇదేమో x ఏమో positive and y ఏమో negative. In this case, you'll get negative values. You'll get negative values. That is why first quadrant and third quadrant are said to be positive relation, and the second quadrant and fourth quadrant are said to be negative in relation. Right? Now, how do you calculate? The variance of x is calculated by just x1 minus x bar for each and every point, all if summed, and by taking average by n, it is called variance of x. Similarly, what do you mean by variance of y? Similarly, same formula. See, variance of x, you can see here. Variance of x is equal to sigma I is equal to 1 to n xi minus x bar whole square by n minus 1. Why we need to put n minus 1? If it is random, in variables are random, we put n minus 1. If they are definite, we put n. That is the difference. So xi minus x bar whole square. So this is called variance of x, my dear friends. This is variance of x. Variance of x. This is called variance of x. Similarly, you can calculate variance of y. What do you mean by covariance between x and y? Covariance between x and y. Same formula. So xi minus x bar into yi minus y bar. See, instead of whole square, we are just calculating xi minus x bar into yi minus y bar by n minus 1. This is called covariance. Covariance antaru. This is called covariance. Hope you understood, right? So again, coming back to variance, sample mean, covariance, correlation, and standard deviation. Let us again see covariance, variance and covariance. How it depends. I'll tell you that also. See, need a measure of association between two variables. By association, we mean strength of a linear relationship between numerical variables. The relationship is strong if the points in a scatter plot cluster tightly around the straight line, tightly around the straight line is called stronger relation. And if this line rises from left to right, then it is called positive relation. left to right is called positive relation, and it falls from left to right, left to right, that is called negative relation. We know that variance of a variable x is variance of x is equal to sigma I is equal to 1 to n xi minus x bar whole square by n minus 1. On a similar note, let's define covariance between x and y as covariance of x comma y is equal to sigma I is equal to 1 to n xi minus x bar into yi minus y bar by n minus 1. Remember, my dear friends, there is no confusion. N minus 1 average, when we go for an average, if the values are not random variables, random samples takapote, we'll take n. If they are random in nature, we will take n minus 1. So let us see now. Now, covariance between x and y is the same as covariance between x and y and x. X and y ki, y and x ki, there is no difference. Covariance between a variable itself is the variance of the variable. It is difficult to interpret the magnitude of a covariance since it is not scale invariant. Right, correlation. Right now, tell me what is called correlation. We can scale covariance to make it an invariant measure of linear association. Correlation between x and y is correlation of x comma y is equal to covariance of x comma y by standard deviation of x into standard deviation of y. So how do we calculate standard deviation? I think you all might be knowing. Now the correlation is always between -1 and +1. The correlation between a variable and itself. The correlation between x and y is the same as the correlation between y and x. Correlation scale is invariant. Now, so by using Python, if correlation coefficient is found using the formula, for instance, the miles per gallon versus weight, the correlation coefficient is minus 0.83. This is minus 0.83. Why it is minus? You can see here, this is negative. If a line is drawn like this is negative. See, negative, negative. This is negative. అంటే weight పెరిగే కొద్దీ miles per gallon తగ్గుతూ ఉంటుంది. So that is why we got, so this, no, we got it as correlation as minus 0.83. Now the conclusion is it is as negative, and MPG miles per gallon is inversely proportional to weight of a car. Weight of a car is inversely proportional to weight of a car. See, our concept is, no, we are in, see, just check how to calculate. Now in the linear regression, then we can even calculate if weight is given, what is the approximate miles per gallon also can be calculated. So that is, if weight is increased, the MPG miles per gallon gets decreased. This is called uh, relation between two features. Relation between two features. So how do you take weight? X-axis లో వెయిట్ తీసుకున్నాం, ఇక్కడ y-axis లో MP మైల్స్ పర్ గ్యాలన్ తీసుకున్నాం. వెయిట్ నేమో ఇండిపెండెంట్ వేరియబుల్ అన్నాం, ఇక్కడేమో ఎంపీజీ నేమో డిపెండెంట్ వేరియబుల్ అన్నాం. ఎందుకని అట్లా అన్నాం? క్వశ్చన్ ఈస్, డూ హెవియర్ కార్స్ హ్యావ్ లోవర్ మైలేజ్? ఈ క్వశ్చన్ లో వెయిట్ ని బట్టి మైలేజ్ మారుతుందా లేదా అని చెప్పమన్నారు. అందుకని we took weight as independent variable and the MPG miles per gallon as dependent variable. So this is how now you can see the correlation coefficient. This is correlation coefficient 1 unte, this is a straight line. 1 unte, it is a straight line. 1 unte, it is a straight line. Plus 0.8 unte, plus 0.8 unte అర్థం ఏంటంటే, see, this is positive in relation, positive, and so y depends on x. Y depends on positively on X. Now 0.4 unte correlation coefficient ila untadi. 0 unte ila untadi. And minus 0.4 unte ila. Minus 0.8 unte ida minus 1 unte ila. So this is called correlation. By calculating the correlation, we can definitely come to a conclusion about the relation between two attributes or two features. You can see here. So if you say these are, see, this is linear. These are all called linear. Idantha kuda linear. Linear. You can also see some non-linear pictures here. This is non-linear. ఇది ఒక ఆర్డర్ లో లేదు, ఒక ఆర్డర్ లో. సో correlation factor is 0, 0, 0. So we cannot apply correlation concept to these non-linear things. In non-linear things we have to go for another one. So this is called correlation, my dear friends. So hope I tried my level best to make you understand about statistics. Hope I am clear, and I made you also clear. So if you have any doubts, I request you to please share. Raise